All right, let's just jump right into an absolutely incredible scientific mystery. It's one that perfectly mashes up modern geology with medieval history. Welcome to this explainer, where we're going to look at one of the most pressing geological puzzles of our time. And the crazy thing? The answer has been hiding in plain sight this whole time, literally carved into ancient stone. Now, you might be wondering, how on earth do you measure an earthquake that happened 5 whole centuries before the seismograph was even invented? I mean, it sounds totally impossible, right? But to prepare for our future, seismologists actually have to figure out exactly how the Earth moved hundreds of years ago. We know the Himalayas are incredibly active. They're constantly being pushed upward by the grinding collision between the Indian and Tibetan tectonic plates. But to grasp the true risk, scientists need data that goes back way further than our modern tech allows. And the reason they need that historical data so desperately comes down to one absolutely crucial number: 600. That represents a 600-kilometer unruptured zone in the Himalayas, known as the Central Gap. Honestly, scientists consider this region a literal ticking time bomb. It's holding the potential for a massive magnitude 8.0 or greater earthquake. To give you a mental map of what we're dealing with here, off to the west, we have the 1905 Kangra earthquake, and way over to the east, the 1934 Nepal-Bihar earthquake. But right smack in the middle, covering the Garhwal and Kumaon provinces, there is just this ominous 600-kilometer stretch of silence. It's a massive deficit in seismic productivity, and it leaves researchers desperately searching for any clues about when this central zone might rupture next and, well, how devastating it could be when it does. Section 1. Ancient Temples as Sensors. Ancient Seismology. So to solve this very modern puzzle, researchers turn to some highly unconventional instruments. They are actually using 1,000-year-old Hindi temples in those provinces I mentioned as literal data recorders, what we call archaeological seismic sensors. But why medieval temples, right? Out of all things? Well, it's because these incredibly heavy stone structures are perfectly, if entirely accidentally, tuned to the Earth. You see, their fundamental time period is under 0.6 seconds. Basically, this means they sway at the exact rhythm of a major earthquake, allowing them to reach a state of partial resonance with the surrounding soil. Because of this little quirk of physics, their resulting damage patterns, you know how they tilt, twist, or slide, permanently lock in the exact fingerprints, magnitude, and direction of past seismic events. It's like a giant puzzle left behind by the Earth. Section 2. The Katyuri Dynasty Builders, 7th to 11th century. Okay, so who actually built these massive stone data sensors? Between the 7th and 11th centuries, it was the Katyuri kings who erected these broad-based, super stable structures. They're usually about 3 to 5 meters high with these tapering tops, and their architecture ended up being perfectly designed to capture seismic data, even though obviously they had absolutely no intention of doing so at the time.
The really brilliant part is that the Katyuri builders used a dry stone architecture technique. They took these massive, heavy rock units and arranged them entirely without mortar. Zero mortar. Sometimes they anchored them with iron brackets, but that's the whole shebang. Because there's no mortar holding it all rigidly together, the temples don't just shatter into dust during a massive earthquake. Instead, the individual blocks sort of slide, rock, and twist, which permanently locks in the exact direction of the ground's movement.
So across centuries of really violent tectonic activity, these temples have stood as silent witnesses. From their establishment around 700 CE on all those massive temple-building campaigns, right through to their decline in the 11th century, their creations endured. They literally recorded the massive medieval quakes in 1255 and 1505, right up to a critical event in 1803 that we're going to talk about in a second. Section 3. The Katarmal Sun Temple. Architectural Marvel. To really wrap our heads around this damage, we need to zoom in on one specific, breathtaking site, the Katarmal Sun Temple. Built in the 9th century by King Katarmala, this whole complex is just an architectural marvel. It sits at an elevation of over 2,100 meters and features a main shrine surrounded by 44 smaller, exquisitely carved temples. Just pause for a second and imagine the sheer physical effort required to quarry and drag these massive stones over the steep, hilly terrain of the Himalayas well over 1,000 years ago.
And here's what experts call the Katarmal paradox. Originally, the builders used absolute mathematical precision so that the very first rays of the sun would fall perfectly straight onto the main idol of the sun god. But today, Well, the roof of the main shrine has completely collapsed, and the pillars of those 44 subordinate temples are violently rotated. It's just a stark physical contrast between pristine human precision and the chaotic twisting force of the Earth's tectonic plates. Section 4. Decoding the seismic damage. Reading the stones. So, how do scientists actually read a twisted pillar to map a fault line? Well, they meticulously catalog the deformation across the entire region. At Bajanath over in Kumaon, the whole complex is tilted south. At the Vandevi Temple and Dwarahat, the entire structure has twisted completely clockwise on its axis. And over in Gardwal at Uttarakhand, total destruction of the temple. By mapping out this highly specific damage, seismologists can basically see the shock waves of ancient earthquakes radiating and dissipating through the mountains. I mean, if you visit Bajanath today, you can literally see how solid stone blocks were just sheared and shoved centimeters apart. Remember, there's no mortar here. The earthquake simply picked these incredibly heavy blocks up and shifted them, leaving behind a permanent ruler that measures the exact violence of the shaking. But to make sense of all these shifts and twists, scientists needed a key. They needed a way to link a specific type of damage to a specific earthquake magnitude. And they found that key in the well-documented magnitude 7.5 earthquake of 1803. They basically used this 1803 event as a Rosetta Stone to calibrate the structural damage we see on the temples. Because the 1803 quake is relatively recent, we actually have written records of it. There's this incredible eyewitness account from 1810 by a Captain Raper describing the temple in Uttarakhand. He wrote it had formerly a temple erected over it, but in the earthquake of 1803, the mansion was thrown down, and wonderful to relate, the pillar escaped without injury. What he's talking about is a massive 12-foot brass and copper trident that miraculously survived perfectly upright, while the heavy stone temple around it was completely leveled. This account tells scientists exactly what a 7.5 magnitude event actually does to these specific structures. Section 5. Preparing for the future. Filling in the blanks. By reading these stones, scientists are finally filling in those terrifying blanks on the map. And that brings us to the most urgent takeaway from this entire explainer, represented by a single number, 500. Based on the damage to these thousands-year-old structures, the estimated interseismic interval for great earthquakes in this region is roughly 500 years. It has been a very, very long time since the last massive rupture in that central gap. The ancient Katyuri builders didn't just leave us beautiful monuments to their gods. Through their unique dry stone architecture, they accidentally left us a highly advanced early warning system. These ruins confirm for us that the 600-kilometer central gap is highly active, and they seriously reinforce the severe threat of an impending magnitude 8 or greater event. More than anything, it absolutely proves that historical architecture is a vital, irreplaceable tool for modern hazard assessment. The rocks of the Himalayas have kept their records faithfully for a millennium, allowing us to prepare for what's coming. But it leaves you with a pretty profound question to think about. When the Earth inevitably decides to move again, how will our own modern monuments fare? What will our glass and steel skyscrapers tell the archaeologists of the future about us 1,000 years from now? Thanks so much for joining me for this explainer. I'll see you next time.